Hi, welcome back to the channel. Let's start with some key points for this video. Engine knocking is likely caused by abnormal combustion, often due to low octane fuel, incorrect ignition timing, or a lean air-fuel mixture. It seems likely that neglecting knocking can lead to reduced engine performance and potential damage, so addressing it promptly is important. Research suggests solutions include using the right fuel, checking ignition timing, and maintaining the fuel system with professional help. Engine knocking, often described as a pinging or knocking sound, occurs due to abnormal combustion in the engine's cylinders. This happens when the fuel-air mixture does not burn in a controlled, progressive manner, but instead explodes, creating pressure waves that result in the characteristic noise. The condition is significant because it can compromise engine performance, lead to increased wear on components like pistons and cylinder walls, and, if ignored, result in catastrophic failure, such as cracked pistons or damaged spark plugs. Neglecting engine knocking can also reduce fuel efficiency, increasing costs for vehicle owners. Below, we analyze 3 primary causes, each with a description, explanation, consequences, and solutions. The octane rating of fuel measures its resistance to knocking when compressed in the engine's cylinder. Lower octane fuels are more prone to premature combustion under high pressure and temperature. When using fuel with a lower octane rating than recommended, like using regular 87 octane in an engine requiring premium 91 or higher, the fuel may detonate before the spark plug fires, leading to multiple explosions and the knocking sound. For example, performance engines or turbocharged vehicles often require higher octane to handle increased compression. This can result in reduced engine performance, as the engine struggles to produce power efficiently, increased fuel consumption due to incomplete combustion, and potential damage to engine parts like pistons and cylinder walls from the high pressure of detonation. Over time, persistent knocking can lead to costly repairs, such as replacing damaged pistons. The primary fix is to use the fuel with the octane rating specified in your vehicle's owner manual. For instance, if your car requires 91 octane, avoid using 87. If knocking persists even with the correct fuel, it may indicate another issue, such as carbon deposits or ignition problems, requiring professional diagnosis. Ignition timing refers to the precise moment the spark plug fires relative to the piston's position, measured in degrees before top dead center. It's critical for ensuring the fuel burns completely and smoothly as the piston reaches the top of its stroke. If the timing is too advanced, spark occurs too early, the fuel can burn too quickly, causing pressure to rise before the piston is in the optimal position, leading to knocking. For example, if the timing is set to fire 40 degrees BTDC when it should be 30, it can cause the flame front to collide with the still compressing mixture, creating the knocking sound. Conversely, timing that's too retarded, too late, may reduce power but is less likely to cause knocking. BTDC stands for before top dead center. In a car engine, this term describes the position of the piston relative to its highest point, top dead center, or TDC, in the cylinder. For instance, when setting ignition timing, the spark plug may fire a few degrees BTDC to ensure optimal combustion as the piston nears the top of its stroke. Incorrect timing can lead to reduced engine power and efficiency, increased fuel consumption, and potential engine damage from the knocking, especially if the timing is significantly off. Over time, this can wear down components and affect overall engine longevity. Have the ignition timing checked and adjusted by a qualified mechanic. This may involve replacing the timing belt or chain if worn, or adjusting the engine control unit settings, particularly in modern vehicles with electronic timing control. Regular maintenance, such as timing belt replacement every 60,000 to 100,000 miles depending on the vehicle, can prevent this issue. A lean air-fuel mixture occurs when there is an excess of air relative to fuel in the engine cylinders, with the ideal ratio for gasoline engines being around 14.7 to 1, air to fuel. This can happen due to issues like a malfunctioning fuel injector, faulty oxygen sensor, or restricted air intake. A lean mixture can lead to higher combustion temperatures, as there's less fuel to cool the combustion process, making the fuel more prone to premature ignition. This can cause the mixture to detonate rather than burn smoothly, resulting in knocking. For instance, a vacuum leak can introduce extra air, creating a lean condition and increasing the risk of knocking, especially under load. The consequences include reduced engine performance and power, increased risk of engine damage from knocking, poor fuel economy due to inefficient combustion, and higher emissions, which can affect environmental compliance. To address this, have the fuel injection system checked for malfunctions, such as clogged injectors, and ensure the oxygen sensor is functioning correctly, as it helps the ECU adjust the mixture. Check the air filter for cleanliness and ensure the intake system is not restricted. For older vehicles with carburetors, adjusting the carburetor may help, though this is less common in modern fuel-injected cars. A mechanic can use diagnostic tools like smoke tests to detect vacuum leaks, providing a thorough fix. While the above causes are primary, it's worth noting other potential contributors to engine knocking, such as carbon deposits, which can create hot spots leading to pre-ignition and subsequent knocking. Carbon buildup is more common in older engines or those with infrequent maintenance and can be addressed with fuel additives or professional cleaning. Additionally, high engine temperatures or worn spark plugs can also contribute, though these are secondary to the main causes discussed. An unexpected detail for readers is that many modern engines are equipped with knock sensors, which detect knocking and adjust ignition timing automatically to mitigate the issue. However, if knocking persists, it indicates a deeper problem that requires professional attention, as sensors can't fix underlying issues like wrong fuel or a lean mixture. This is particularly relevant for vehicles manufactured in the last decade, where electronic controls are standard. To prevent engine knocking, vehicle owners should prioritize regular maintenance. Using the recommended octane rating fuel, as specified in the owner's manual, 87 for most standard engines, higher for performance or turbocharged models. Scheduling periodic checks of ignition timing, especially during major services like timing belt replacement. Ensuring the fuel and air systems are maintained, with regular oil changes, air filter replacements, and spark plug checks every 30,000 to 60,000 miles depending on the vehicle. Addressing any knocking sounds promptly by having the vehicle inspected by a professional mechanic to diagnose and repair the issue before it escalates. In conclusion, engine knocking is a preventable condition with clear causes and solutions. By understanding factors like low octane fuel, incorrect ignition timing, and lean air fuel mixtures, and taking proactive steps, you can protect your engine's longevity and performance. Acting quickly at the first sign of knocking is crucial to avoid costly repairs and ensure your vehicle remains reliable.